Hi, algebra students. This is Mrs. Lorenz. I'm sorry I can't be there today, but you are in good hands. I wanted to do a quick little video for you to talk about solving literal equations. And then when I'm done, the sub will pause it, not pause it, but go through a couple more examples for you. And then you guys will have some time this period to practice this. So you should be taking notes wherever you normally take notes, like if I was there in class with you. Feel free to ask for the video to be paused if you need some time to catch up and write something down or go back and get something that you missed. Okay, so we've been solving equations. Now we're going to talk about solving literal equations. So what are they and why do we need this? So literal equations are just equations that are going to have more than one variable in them. So when we solve, we're not going to get answers like x equals 3. We're going to get answers that have other variables in them. But your goal is still just get the variable alone that you're trying to solve for. So why do we need to do this? We use this a lot when we're trying to rewrite formulas to make them easier to solve for. Like in science, you might have a formula, let's say, that converts Fahrenheit into Celsius, but it might be more convenient to have it convert Celsius into Fahrenheit. So then we would solve it for the other variable. So let's just practice it for the sake of practicing first, and then we'll look at a couple of formulas towards the end. Okay, a couple examples here, and make sure you write down the steps over on the side. How do we do this? Basically, we move everything except for the variable that we're trying to solve for. Just like before, when we had all numbers and one variable, we're going to take care of addition and subtraction first, and then we're going to do multiplication and division last. So if I'm taking a look at this first equation, the first thing I want you to notice is that we're solving for, there's 4 variables there, right? So we have to know which one are we solving for, because that's the one we're trying to get alone. So we're trying to solve for A. So there are my 2 sides of the equation, just like usual. And A is the thing I want alone, which means anything over here with A, this plus K, I need to get rid of. So to get rid of that, I'm going to subtract it. K minus K is going to be 0. But then I have to subtract it from the other side. Here's my 0 pair, so I just have A equals. And over here, there are no like terms. W, V, and K are not the same, so I just have that. Right? My job was to get A alone, and that's what I did. So we're good. I know it doesn't seem like that makes a whole lot of sense. Like, well, what does that mean about A? It just means that A is equal to W plus V minus K. Okay, solve for M. Let's do the same thing. Here's M. So P has to go and A has to go. So I'm going to subtract P from both sides. 0 pair goes away. A times M equals N minus P. Again, those are not like terms, so I cannot combine them. And then again, A is the thing. You have to keep reminding yourself, M is the thing I'm trying to get alone. So I have to remind myself, okay, then A is the thing. It would be really easy to forget that and divide by the wrong thing. But what I want to get rid of is the A. So I will divide by A here, but I have to divide all of this by A. So M equals N minus P, the whole thing divided by A. We're going to add in some more numbers in a minute, but I just wanted you to see it with lots of variables. I'm just going to do like a side note over here. Like I'm solving this for M. It's very similar to if I'd had like 5M plus 10 equals, I don't know, let's say 12. Just like I subtracted the P first here to the other side, I would do the same thing if it had been a number. I would have subtracted 10. The only difference with this is that for this example over here, I'm able to actually combine like terms. Here I don't have like terms, so I can't combine them. That's really the only difference. And then I would divide by 5, just like we divided by A to get the M alone. And I have 2 over 5. Okay, so very, very similar right there when you look at those side by side. Okay, let's solve this one for y. So I need to leave this here, and I need to get rid of the rest of it. So minus 2x minus 2x. That's my 0 pair. So I'm left with negative 3y equals 12 minus 2x. Then I'm going to divide by negative 3. So that cancels out, and I just get y. But we have to divide everything on the other side by negative 3 also. So be careful here. This is 12 over negative 3 minus 2 over negative 3. So we want to simplify that. So 12 over negative 3 is negative 4. And then 2 over 3 doesn't really simplify, but I could get a negative divided by a negative here, right? That's a minus 2 divided by negative 3. I could change that to a plus 2/3 x. Okay, so make sure that when you're dividing, you divide everything. And sometimes stuff simplifies like it did here, and then one like this doesn't really simplify so much. Okay, let's look at a couple formulas. So solving for t, hopefully this formula is maybe familiar to you. Distance equals rate times time. Right now, it's a formula that we have solved for distance. So this is convenient to use if I know the rate and the time, and I can just plug those in and figure out what's the distance, right? Like if I'm like, oh, you drove, don't write this, 50 miles an hour for 3 hours. How far did you go? 50 times 3 is 150 miles, okay? But if I'm not solving for distance, if I know the distance and maybe time and want to find the rate, it would be better to solve for one of the other variables. So this is asking us to solve this for time. So I want time to be alone. Well, if I want to get time alone, I have to get rid of the r, and those two are connected with multiplication, so we will just divide. So time equals distance divided by rate. So it's just a different way to sort of manipulate that formula to use it in a way that might be better for us given the information we have. Okay, this one is perimeter of a rectangle, right? So just a reminder, you have two widths that are the same, so that's why 2w, and you have two lengths that are the same, so 2 lengths. And we add those together, right? All 4 sides, right? We have 2 of these, add them together to end up with perimeter. So right now this formula is solved for perimeter. It's handy. If you knew this was 5 and this was 2, then you could plug those things in. 2 times 5 plus 2 times w, which is 2, and figure out the perimeter is 14. But if you know the perimeter and you know, let's say, the width, then it would be easier, or better, I should say, more efficient to have this thing solved for length to figure that out. So let's go ahead and get length alone here. I'm going to subtract the 2w because I do addition and subtraction first. Those cancel. Over here I have p minus 2w equals 2l. And then again, I want that L alone, so I'm going to divide by 2, and I divide everything over here by 2. So I have this. The key is making sure you show that everything is divided by 2. So honestly, I'm okay with this answer, or you could actually break it up like I did in the last one, like do P over 2 minus 2W over 2 equals length. P over 2 does not simplify, but the 2 over 2 does. So that would be an alternative answer you could have. But in either case, notice I got L by itself, so I solved for L. Okay, one last problem, and then that will be the end of the video notes, and then you'll have some more examples to work through in class together. Okay, I'm going to try to solve this for y. So again, keeping this on this side by itself, or trying to get it by itself and move all the other stuff. So I would do addition and subtraction first. So 3w left here. Nothing that can be combined over here. So 12x plus 21. Divide by 3, divide by 3. And again, I want to divide both of these by 3. So if it's easier, you can kind of separate it like that. 12 over 3 is 4, and 21 over 3 is 7. So again, my job was get y alone, and that's what I did. Okay, we will review when I return. Remember, you have some extra examples to add, and then work on the CYU. See you guys next class.